Hi everyone, I'm here to lead you through polynomial long division and synthetic division. Polynomial and synthetic division are additional factoring tools on top of the methods we already know, right? So we have talked about how to factor using boxes. We've also talked about how to factor by grouping. These are just more tools that help us solve, and really we're only going to use them for polynomials that are bigger than quadratic. So something like x to the power of 3, or even more so x to the power of 4, sometimes x to the power of 5. So we're using these to help us factor those higher degree polynomials. The two ways we're going to talk about going are synthetic division, which is much easier and it's actually much quicker. And it can be used anytime that we are trying to factor a linear polynomial into the bigger equation. In other words, whenever we're dividing by a linear factor. Linear factor being like x minus 3 or 3x plus 1. So if we're dividing by something linear, we want to use synthetic division every time. If we're not dividing by something linear, then we're going to have to use long division. And that's actually what we're going to start with. So what I mean by nonlinear, that'd be like an x squared plus 3, or in a 2x squared minus x plus 4. Okay, anytime we're dividing by these terms, we're going to need long division. So let's talk about long division. Our setup is very similar to how you would do long division with numbers. Underneath this division symbol, we're going to put everything we're dividing by. Now, one thing we need to keep in mind, we need a term for every polynomial in this equation. So what I mean by that is this is a quartic term. There's no cubic term or anything that has an x to the power of 3. We still need to add that in there. So what we can do is we can add in 0x cubed, which is just a placeholder, right? Adding 0x cubed, I'm not changing this equation at all. That 0 is just there. So that way all of our terms line up as we work through the division. So we need placeholders for any missing term that we don't have in the equation. So then I see a 7x squared, but once again, we're missing a linear term. So we need a 0x to serve as a placeholder. And then we have plus 10 at the very end. What we're dividing by, x squared plus 2, is going to go on the outside here. Now, just like what we did on the inside, if we're missing any terms, like there's no linear term here, we need a placeholder there, so we need that 0x. All right, so here's how this process goes. What we're trying to accomplish is we want to subtract away another x to the 4th and keep reducing down this equation until we get something smaller than an x squared. So I'm focused on this first term here, that x squared. And I ask myself, x squared times what will give me x to the 4th? And we would say another x squared, right? X squared times x squared is x to the 4th. So once we have determined what that value is to allow us to subtract away this first term, we're going to take what we put up top here and multiply it by every single thing. So we already did x squared times x squared, but now we need to do x squared times 0x, which is 0x cubed. I also need to do x squared times positive 2 to get 2x squared. Now I'm going to subtract away all these terms. So I put parentheses around these just as a reminder to myself that the signs I see here are not the signs I'm going to use when I combine like terms here, because we are subtracting. So this is x to the 4th minus x to the 4th. Those cancel out, so we don't need to do anything with them. 0x cubed minus 0x cubed also cancels out, so we don't have any x cubes either. But now when I get to 7x squared minus 2x squared, that is just 5x squared. It's really common to say that this is 9x squared. But that's only if we're adding. We need to remember that we are subtracting. 7 minus 2 is 5. So now that first step is done. Once we get something below the subtraction line, we're going to bring down the remaining terms. So 0x and 10. And we repeat the process until we have something that is a smaller exponent than what we're dividing by. So right now I still have an x squareds. We still have x squareds for what we're dividing by. So I need to subtract away 5x squared to get those terms to cancel out. So x squared times a positive 5 will give me that 5x squared and 0x and plus 10 after multiplying by every single thing. And I'm going to subtract away all these terms. And what happens is they all cancel out, right? 5 minus 5 is 0. 0 minus 0 is 0. 10 minus 10 is 0. And so we're left with 0, which is our remainder. Getting a remainder of 0 is really what we are trying to accomplish. If we get a remainder of 0, we have used this long division to help us factor. So what we really just did is we took this x to the fourth plus 7x squared plus 10, and we factored it to be x squared plus 2 times what we got as our quotient, or the result of the division problem, which is x squared plus 5. So these represent the same thing. And so the long division allows us to factor, which is then going to help us solve this equation down the road. And that's it. So let's do another long division, and then I'm going to show you synthetic division side by side. And we'll do one more synthetic division. So let's do this with a quadratic. And yes, we absolutely could factor this using a tool we already know, but we're going to use long division just to get the practice with it. So we're dividing 3x squared minus 29x plus 56. There are no missing terms here, so we don't need any placeholders. Same with what we're dividing by. I have x minus 7. There are no missing terms. So what I'm first trying to accomplish is to get rid of 3x squared. So x times 3x gives me that 3x squared. So 3x times x is 3x squared. 3x times negative 7 is negative 21x. And we're subtracting all these terms. So 3x squared minus 3x squared cancels. Negative 29 minus negative 21 really means we're adding 21 to get negative 8x. Now that I've done my subtraction, I'm going to bring down the remaining terms, which is just this 56. And I'm going to repeat. So now x times what gives me negative 8x? That'd be negative 8. Negative 8 times x, negative 8x, negative 8 times negative 7, it's positive 56. We're going to subtract all these terms. Negative 8 minus negative 8 is positive 8. 56 minus 56 is 0. So once again, because we have a remainder of 0, what we've just done is we've taken the quadratic of 3x squared minus 29x plus 56, and we have factored it to be 3x minus 8 times x minus 7. And that's it. So if we were to get a remainder that is not 0, it doesn't help us factor. It doesn't tell us anything. It's going to happen, especially when you work on the Math Excel assignment. But really what we're going to use this for moving forward is to help us factor. So we want to find remainders of 0. But it's going to happen sometimes where we won't get that remainder. All right. So that's long division. But now let's talk about synthetic division, which is much quicker and much more, in my opinion, much easier. So with synthetic division, you're going to always start with this half box that I call the chair. We need to put a number in that chair. We're going to get that number by taking what we're dividing by, in this case, x minus 7, and setting it equal to 0. So if I take x minus 7, set it equal to 0, I need to add 7, and I get x equals 7. So 7 is what goes in the chair. Once I have a number in the chair, we're only going to use the coefficients of the equation of what we're dividing. So that's just the numbers. We don't want x squareds. We don't want x's. Just 3, just negative 29, and just 56. I'm going to put a big bar here, and this is an addition bar, which is nice. We don't have to think about that sign change when we subtract like we did with long division. So with synthetic division, your first step is to always bring down the first number. You don't do anything to it. Once I have a number below this addition line, we're going to get another value below that negative 29 by taking this number and multiplying it by the number in the chair. So 3 times 7 is 21. Negative 29 plus 21 is negative 8. This was times 7. Once we get a number below this line, we're once again going to multiply by the number in the chair. So times 7, negative 8 times 7 is negative 56. 56 minus 56 is 0. So the last number with synthetic division, that's going to always be a remainder. That's that same remainder we got here. So 0 is our remainder. And then these other numbers, I always interpret them by going right to left. So working my way to the left-hand side. The reason I do that is because the number immediately to the left of your remainder is your constant term, meaning it doesn't have any x's. It's just a number. So that's just -8. The next term to the left of your constant term is your linear term, which are just x's. So really this is 3x minus 8. That same 3x minus 8 we got by doing long division. So really, once again, we have just factored this whole quadratic to be x minus 7 times 3x minus 8. All right, let's do one more synthetic division because there's an additional thing we need to pay attention to for when we're dividing by a linear term that has a number in front of the x. So here we have that 7x. So our setup is still the same. I'm going to take 7x plus 6 and set it equal to 0. I'm going to subtract 6 and divide by 7. I get -6/7. I'm going to put -6/7 or -6 divided by 7 in the chair, and we're going to bring down all the coefficients. So 7, 62, 34, and -12. And we're going to, again, have this addition bar. The first number always comes down unchanged. So now, we need to take 7 and multiply it by -6/7. There's absolutely nothing wrong with using a calculator. If I'm using a calculator, the one thing that you absolutely need to do is you need to put the fraction in parentheses. So if I want to take 7 and multiply it by this fraction, I'm going to go 7 times, and in parentheses, a fraction is nothing more than a division problem. So I'm going -6 divided by 7. And that gives me -6. You could come up with this value of -6 really easily without the use of a calculator. So how can we do that? When we're multiplying by -6/7, we're really doing two operations. We're taking this number, we're dividing it by 7, and we're multiplying it by -6. So if we do those two things, we'll come up with -6. So here's what I think about. I go 7 divided by 7 is 1. 1 times -6 is -6. There's that value. Then we'll add these together to get 56. Once again, I need to take 56 and multiply it by the number on the chair. So I'm going to go 56 divided by 7 is 8. 8 times -6 is -48. 34 minus 48 is -14. Once again, I need to multiply by the number in the chair. -14 divided by 7 is -2. And -2 times -6 is 12. When I add these numbers together, it gets me that remainder of 0. So once again, the number at the very end is your remainder. That number stays the way it is. We're not going to do anything to it. But these other numbers, we have to do one thing to them, and that's only when the number in front of the x is something other than 1. So since we have this 7 here, we need to divide all of these numbers by 7, or by whatever is in front of that x. So I'm going to take all those values, I'm going to divide them by 7. So 7 divided by 7 is 1. 56 divided by 7 is 8. -14 divided by 7 is -2. These are the numbers that we're looking for, and these are the numbers that we're going to use as the result of the division problem. So we already know that 0 is our remainder, making -2 your constant term, making 8 your linear term, so it has an x, and 1 your quadratic term, so x squared. So really, this whole term, or this whole result of our division, is x squared plus 8x minus 2. And so once again, what we've done is we've taken this whole cubic, so 7x cubed plus 62x squared plus 34x minus 12, and we have factored it to be 7x plus 6 times x squared plus 8x minus 2, which is really, really powerful and helpful for us to solve, which we're going to do down the road. All right, well, that's all I got for you today. Thanks for watching. Have a great rest of your day.